Hello, in this video we will discuss about arithmetic progression. Okay, so this is our first video on arithmetic progression, and in this session we will particularly discuss about the basic terminology related to the arithmetic progression. So first of all, let us discuss what do we mean by arithmetic progression. So in a very simple manner we can define an arithmetic progression as an arrangement. So we can say that an arrangement of elements, or in some cases we can also say that numbers, such that the difference between two consecutive terms is fixed. Okay, so this is a very simple definition of an arithmetic progression. So basically what do we mean by this definition? That suppose we are having an arrangement like we are having a1, a2, a3, a4. So we are having these type of terms. So if you consider a2 minus a1, so that will be same as a3 minus a2, and this will be same as a4 minus a3, and of course so on if we continue with the differences. So here this a1 is known as the first term of the arithmetic progression, and this fixed difference between two consecutive terms means a2 minus a1, a3 minus a2. So we are having this difference is defined as d, which is the common difference. Okay, so this is what do we mean by the fixed difference or the common difference. So common difference is the difference between any two consecutive terms, and for an AP it will be fixed or same. Now in order to determine an AP, we have to find out, or we have a clear information on a1 means the first term of the AP and the common difference of the AP. Next we can have some simple problems on this AP. Means in many cases we are given an arrangement and we have to verify that whether the given arrangement is an AP or not. So let us begin with our first example. So we are given that 2 upon 5, 8 upon 5, 14 upon 5, 4, and so on. And what we have to do, we have to just check whether this arrangement is an AP or not. So what you have to do, in order to check whether this arrangement is an AP or not, you have to find out the differences between two consecutive terms. So let us begin with 8 upon 5 minus 2 upon 5. So if you take the LCM, so that will be 5, and we are having 8 minus 2. So the difference between the second term and the first term is 8 by 5 minus 2 by 5, which is coming out as 6 by 5. Next, we will find out the difference between A3 minus A2, and that will be 14 upon 5 minus 8 upon 5. So again we will take the LCM, so that will be 14 minus 8, and it is coming out as 6 upon 5. On the same line, we can find out the next difference, so that will be A4 minus A3. So our A4 is 4 minus A3, which is 14 minus 5. So again this can be written as 20 minus 14 if you take the LCM as 5. So this is again 6 by 5. So from this calculation we can conclude, or this implies, that A2 minus A1 will be same as A3 minus A2, which is same as A4 minus A3, and so on. So since the difference between two consecutive terms is same, so this implies that this given arrangement is an AP. Okay. Now let us discuss some more examples. So let us have another example. So here we are given that this square root of 2, square root of 18, square root of 50, and square root of 98. And again we have to find out the whether this arrangement is forming an AP or not. So you can say that again you can identify this first term as A1, this second term as A2, this is our A3, this is our A4. So you can, whenever we are having this type of arrangement, or means this square root of 2, square root of 18, so maximum time we will try to break these numbers as a product of two numbers, out of which at least one is the perfect square. So let us begin that this root 2, so this is this cannot be break into the product of two numbers where one is complete square, so we will keep it as it is. Now if you consider this 18, so this can be written as, this 18 can be written as 9 into 2. So since 9 is the perfect square, so we can write this as 3 square root 2. Now the next term is 50, and you can again break it as 25 into 2, which is coming out as 5 square root 2. Next we have 98, so you can write it as 49 into 2, so this can be written as 7 square root 2. So we can rewrite this given arrangement as, so we can rewrite this arrangement as root 2. We have this as 3 square root 2, 5 times square root 2, 7 times square root 2, and so on. So now if you have to check that this is this forming an AP, so what is the process? The process is same. So we will now we can mark this as this. So this is our A1, this is our A2, this is our A3, this is our A4. So again we will find out the differences. So A2 minus A1 will be 3 root 2 minus root 2. So this is 3 times root 2. It is simple 1, or you can mark it as 1 times root 2. So 3 minus 1 will be 2 root 2. Now next is A3 minus A2. So that will be 5 times root 2 minus 3 times root 2. So 5 minus 3 is 2. So this is again 2 root 2. Next we will find out A4 minus A3. So this will be 7 root 2 minus 3 times root 2. So this is coming out as 4 times root 2. So again okay, so here we have a correction. So basically this is not this is not 3 root 2, this is 7 root 2 minus 5 root 2. Okay, so this is because A3 is 5 root 2. So this can be written as 2 root 2 because 7 minus 5 is again 2. So from here again you can see that the differences are fixed. So from here you can conclude that it is forming an AP. Now let us discuss another example, one more example. So this is we are having this again we are given an arrangement which is 1 upon 5, 1 upon 15, 1 upon 45, 1 upon 135 and so on. And again we have to check whether it is an AP or not. So again from this given arrangement we can mark this as A1, this as A2, 1 upon 45 as A3, A4 and so on. So again the process is same. We will take the difference A2 minus A1. So that will be 1 upon 15 minus 1 upon 5. So if you take this as LCM as 15, so you will get 1 minus 3. So this is minus 2 upon 15. Now you have A3 minus A2. So that will be 1 upon 45 minus 1 upon 15. So this is, if you take the LCM as 45, so this is again 1 minus 3. So it is coming out as minus 2 upon 45. So as you can see that our A2 minus okay, so this is A2 minus A1. So this is our A2. So this is our A2 minus A1. Okay, A2 minus A1. So from these two differences it is very much clear that our A2 minus A1 is not same as A3 minus A2. So we don't need to find out more differences because as we can see that the difference between A2 and A1 and A3 and A2 are not same. So this is enough to conclude that this is not an AP. So on the same line, let us discuss some problem, in fact some more problem on the basic definition of AP. So we are given that, so in the next problem we have to find the values of A and B such that A comma 9, B 25 is forming or is forming an AP. Okay, so we are given that the difference, the terms as A comma 9, B and 25. So if these terms are forming AP, so again, so let us begin with the solution. So for AP we have 9 minus A should be same as B minus 9. So this is let us consider this as equation 1. And next we have 25 minus B as B minus 9. So this is our equation 2. So from 2 we have that if you just rearrangement the terms, so you will get 2B is equals to 34. So this implies B is coming out as 17. Okay, so this B is coming out as 17. Now next, using the value of B in 1. So 1 in 1 what we are having? We are having 9 minus A is equals to B minus 9. So this implies 9 minus A is equals to 7 minus 9, which is coming out as 8. So this further implies that nine minus A is equals to 8. So from here you will obtain that 9 A is equals to 9 minus 8, which is 1. So in this way we can find out the values of unknowns if we are provided the information that some arrangement like this A 9 B 25 is forming an AP. Now in the next problem we will discuss an interesting one. I hope that all of you are aware about the formulas A minus B whole square, A square plus B square and A plus B whole square. So here we have to show that they are forming an AP. Okay, so again the process is same, means if they are forming an AP, so let us begin with the solution. So we know that if they are forming an AP, so the difference between the second and first and third and second will be same. So First of all, we will just simplify these terms. So a minus b whole square can be written as, so it is a very popular formula, and we know that this can be written as a square plus b square minus 2ab. And same, we know that a plus b whole square will be a square plus b square minus plus 2ab. So using this, so now the given arrangement can be written as so now the first term is a minus b whole square, so we have a square plus b square minus 2ab, a square b square, and we are having a square plus b square plus 2ab. So now if you take the difference, so means a2 minus a1, so that can be written as a square plus b square, this is our a2, minus a1, so that is a square plus b square minus 2ab. So from here you will obtain this as a square plus b square minus a square minus b square, and this minus will convert this minus as plus, so we have plus 2ab. So you can see that we obtain, or we left with this difference as 2ab. Now if you take the next difference, so this is a3 minus a2, which is a square plus b square plus 2ab minus a square plus b square. So this is our a3. So from here you obtain this as a square plus b square plus 2ab minus a square minus b square. So this is again coming out as 2ab. So this implies that you are having a2 minus a1 is equals to a3 minus a2. So this further implies that the given terms are forming an AP. Now if so next we will have some problems, even in fact some more problems, but this time with the word problems. So if you just see that sometimes we are given these type of word problems. Okay, so if you look at this first problem, so we are provided number of students left in the school campus from the total strength of 750 students when they leave the campus in batches of 30. So we have to check whether we will get an AP or not in this situation. So if so we are so let us discuss the solution of this problem. So the total strength is given as 750. Okay, and students are leaving in a batch of 30. So let us consider this 750, which is the initial or the total population of the students in the campus, as A. Now if the first batch left the campus, So our remaining students will be 750. You can write this as A2 and you can write this as A1. So the remaining students will be 750 minus 30, because initially we are having 750 students and 30 students have left the campus. So we are having this as 720. Now next we obtained the third term as 720, because now if the first batch already left the campus, so the remaining students, when the next batch left the campus, will be 720 minus 30, so this will be 690. And similarly you can obtain some more terms. So the next term can be obtained by 690 minus 30, so this is 660. So now we can write this as, so initially we are having 750 students, after that we are having 720 students, next we are having 690 students, then 660 students, and so on. So if you look at this arrangement, so again our A1 is 750, our A2 is 720, our A3 is 690, and A4 is 660. Okay, so again if we have to check whether we are getting an AP or not, so you can see that A2 minus A1 is 720 minus 750, so that will be minus 30. Then we are having A3 minus A2, so that will be 690 minus 720, so this is minus 30. Next we are having A4 minus A3, so that is 660 minus 690, so this is again coming out as minus 30, and so on. So again we can see that the differences between two terms is fixed. So difference between two terms is fixed. So this implies that we are having an AP. Now let us have one more word problem on this AP. So in the next problem you can see that we are given that the amount of air present in the cylinder when a vacuum pump removes each time 1/3 of the air left in the cylinder. So we are given this problem and we have to check whether we are getting an AP or not in this situation. So let us begin with the solution. So let us assume that initially, the air in the cylinder can be considered as X. Okay, so this is our supposition. Now what is happening that the vacuum pump is removing every time 1/3 of the air present in the cylinder. So initially we are having the air as X, or the volume of the air as X, so that the pump will remove 1/3, so X minus X3, so this is 2X minus 2X by 3. Okay, so because X minus X3 will be 2X by 3. Now the next we have, because the air in the cylinder is 2X by 3, so now again the pump will remove 1/3 of 2X by 3, because now we are left with only 2X by 3 amount of air. and the pump is removing the 1/3 of the amount present in the cylinder. So 2x by 3 is present in the cylinder, so this is 1 by 3, 2x by 3, so that is 2x by 3 minus 2x by 9. So this is coming out as 6x minus 2x upon 9. Okay, so this is coming out as 4x by 9. Okay, now you can let us have one more term. So now we are left with only 4x by 9 amount of air in the cylinder. So now next, what is the role of the vacuum pump? So it is removing the 1/3 of the amount present in the cylinder. So amount in the cylinder is 4x by 9. So this is 4x by 9 minus 4x by 27. So this, if you take this 27 as the LCM, so this is 4x minus, sorry, this is not 4x, and this is so we are having 27 as LCM, so this is 12x minus 4x, so which is coming out as 8x over 27. So now we are having, initially we are having x, now next we are having 2x by 3, next we are having 4x by 9, next we are having 8x by 27, and so on. So now if we have to check whether it is an AP or not, so again we have to do the same thing. So this is again, let us mark that this is our A1, this is A2, this is A3, and the last one as A4, and so on. So if you have to subtract A1 from A2, so that will be 2x by 3 minus x, so that is coming out as 2x minus 3x upon 3. If you are taking this 3 as LCM, so it is minus x by 3. Now next we are having A3 minus A2, so A3 is 4x by 9 minus 2x by 3, so it is, if you take the LCM as 9, so it is 4x minus 6x, so it is coming out as minus 2x by 9. So as you can see that A2 minus A1 is not same as A3 minus, so A2 minus A1 is not same as A3 minus A2, so we don't need to find further differences, because this evidence is enough to conclude that this is not an AP. So in this situation we are not getting an AP, right? So this is how we can handle the problem related to the fundamental definition of AP, which is the difference between two consecutive terms is fixed. Okay, so that's all, and in the next video we will discuss about the general term on of an AP and the problems related to the same. Okay.